In this video, we are going to take a quadratic function, that's y equals x squared, it makes a parabola, and then graph a new function and see how the parabola has changed. So in order for us to do this, we're going to start by taking this original equation. This is called the parent function. We talked a lot about this in the last class. So I'm typing in f of x equals x squared into Desmos to see what this graph looks like. So I'm doing f parentheses x equals x squared. I like for my graphs to be red, so I went to settings and I'm just changing it to red. Okay, so here is my red parent function. The parent function of a parabola has a vertex where it touches at the origin, which is 0, 0. It's always opening upward in the quadratic parent function, and there's a point that goes up 1, right 1, and left 1, up 1, left 1. Okay, so to be able to graph that on our worksheet, what we're going to do is I'm going to start by graphing the origin at 0, 0. Then we said the parent function goes up 1 and right 1, up 1 and left 1. Okay, so here is a picture of my quadratic parent function. So now we're going to take that parent function, y equals x squared, or f of x equals x squared, but this time we're going to add 3 to it. So we're going to go to Desmos, and I type in f parentheses x equals x squared plus 3. So if you look at this new graph, I'm going to change this color settings. Instead of green, I'm going to make it blue, just out of preference. So in my blue graph, what you notice is it still has an upward shape, but this one has an origin of 3. It still goes up 1 over 1 to the right, up 1 over 1 to the left. So it doesn't get wider or narrower. It just moved up 3. So to graph that, instead of graphing at 0, 0, it starts at 0, 3. Then again, it goes up 1 to the right 1, up 1 to the left 1, and it still makes this same U shape. So what happened from when we just had x squared to now we have x squared plus 3? What happened to my graph is it shifted up 3. So we're going to do that again, but this time we're going to discover the change of this one here. So again, it says start with my parent function. So I'm just going to have my parent function right here. So it's f of x equals x squared. You guys should be getting pretty good at drawing this parent function. It starts at 0, 0, goes up 1, right 1, up 1, left 1, connect your dots, and that's the parabola. So now in this one, it wants you to see what happens when we do f of x equals x squared minus 4. F parentheses x equals x squared. So now minus 4, I want you to take a second. What do you think is going to happen to this graph? Where do you think this graph is going to go when we're now putting a minus 4 in the back? Here it is. So what happened to my graph is the width is the same. I know that's hard to tell, but in this one here, my parent function, it was at 0, 0, and there's a point right here where it goes up 1, right 1, and on the left side, there's a point where it goes up 1, left 1. Okay, so same thing here. Here's my vertex. It's still going up 1 over 1, up 1 over 1. So the width of the graph is the same, but the difference is that minus 4 in the back made this graph shift down 4. There's still up 1, right 1, up 1, left 1, connect your dots. So what happens when I went from a regular x squared to an x squared with a minus 4 in the back? The minus 4 in the back made this graph move down 4. So now we're going to write a rule. Make a rule. A number in the back shifts the graph up or down. If it's positive, it's going to go up. If it's a minus sign, it's going to go down. Okay? So if there's just a number that hangs out in the back, it's going to shift my graph up or down. Easy. So now here's the next change that we're going to have to do. We have a couple of them left. We're going to do the exact idea. So again, we're starting with our parent function, f of x equals x squared. Here she is. The parent function, 0, 0, is my vertex. It's opening up. So my vertex of this one here is still at 0, 0. It still goes up 1, over 1, up 1, over 1. Connect your dots, and there's your graph. So now I'm going to take this same idea, and I'm going to plug this one into Desmos. F of x equals x plus 4, close parentheses, squared. So parentheses x plus 4, close parentheses, squared. Let's make sure I type that in correctly. X plus 4, parentheses squared, I did. So what happened here is the graph did not move up or down. My graph was here at the origin, and now it's over here. It moved to the left. You scared of that? It went to the left 4 units. So I'm going to graph it. This one went to the left 4. It still goes up 1 over 1, up 1 over 1. To make that U shape, it's here, and it's here. And then we make our U shape. So what happened? For my original parent function, this guy right here, whoops, that's fancy. So from my original parent function to my new quadratic function where it went x plus 4, close parentheses, squared, what happened? It went to the left 4 units. So this one moved left 4. Let's do that one more time. F of x equals x squared. F of x equals x minus 2 squared. So the first one stays. The new one, f parentheses x equals open parentheses x minus 2. Whoopsie daisies. Press the wrong button. There it is. Ugh, I don't want that color. Hold on. Change settings. Let's make it blue. All right, here it is. So here is my original parent function. It was at 0, 0. Here is my new function. Now it's at 2, 0. So I'm going to graph my original parent function. The parent function is always y equals x squared. It starts at 0, 0, goes up 1 over 1, makes a U shape. This new graph, when I graphed it in Desmos, what I notice is it goes to the right 2 units. Up 1 over 1, up 1 over 1. Connect your dots. So what happened here? My graph went to the right 2. It went to the right 2. So the rule here, a number in parentheses, a number in parentheses. The number is inside the parentheses. It's this guy right here. The number inside the parentheses makes the graph shift left or right. A number inside parentheses makes a graph shift left or right. But this is what's weird. So this one is a plus 4. You would think that positive would go to the right 4, but it doesn't. The plus sign always goes to the left. So if you have a plus, if you have a plus inside those parentheses, if this number right here had a plus sign, it's going to go to the left. If it's a minus sign in parentheses, it's going to go to the right. So the way that I always say that is it's the opposite of its sign. What that means is if it's a plus sign, we're not going to the right 2 or 3 or 4, we're going to the left. If it's a minus sign, my graph shifts to the right. So when there's a number inside the parentheses, it shifts left or right. Okay? So we have 2 more to discover, and then we're going to put it all together. This one's super easy. There's just one of them, and you've seen this before. So the first one, f of x equals x squared. You know how to do this. We've done it 4,000 times. Starts at 0, 0, up 1 over 1, up 1 over 1, connect your dots. That's the parent function. And this one here, it's the parent function, but the only difference is that this time it's a negative x squared. What happens when I threw a negative in front of my x squared? It flipped, it reflected, it opens down. So it still touches a 0, 0, but now we're going down 1 and over 1 to make the U shape. So a negative in front makes my graph flip. In math, the word for flip is the word reflect. It's not a very good parenthesis. Okay, what happens? It flipped. So if you have a negative in front of the parentheses, it is going to make my graph flip or reflect. Not too bad. Okay, last but not least, discover the change. Here we go. F of x equals x squared. We know that. 0, 0, up 1 over 1, up 1 over 1. Connect your dots. Super easy. Let's graph the next one. The next one says f of x equals 5x squared. Woo! Here's my red graph. It touches at 0, 0. Here's my blue graph. It still touches at 0, 0, but it got skinnier. We talked about that last time. If you ran 5 miles, you're going to become more narrow. So this one here is not going up 1 over 1 because it's getting narrower. So what happened? It got narrower, skinnier, más flaca. A number in front made my graph narrower. Again, the parent function, we know how to do that. I'm going to just graph it. 0, 0, 1, 1. Connect your dots. Desmos, let's see. F of x equals 1/2 x squared. Here it is. My red graph touches at 0, 0. It goes up 1 over 1. My blue graph touches at 0, 0, but it gets wider. It like goes up 1 and over like 1.5. Okay, so this one still touches at 0, 0. But it became wider. So I'm just going to sketch a graph that gets wider. So this graph became wider. So a number in front of the x squared, if it's in the front of the x squared, it makes it narrower or wider. Okay, not too bad. So now let's take this and let's remove Desmos from our brains. So this time we can figure out where graphs are going to move. We can describe the change without even looking at Desmos. So in your packets, let's go ahead and find the paper that says function, notation, parameter changes. A parameter change just means that you have a graph and it moves. That's all that means. Very easy. So we just said a lot of things. The first thing that we talked about is the number in the back. The number in the back of an equation moves the graph. The word is shifts. It shifts the graph up or down. So if this back number said +2, then it would go up 2. Then we talked about the number that was inside the parentheses. If the number is inside parentheses, it shifts left or right. You just saw that in Desmos. When I gave you a number that was inside the parentheses, it moved your graph left and right. But remember, it's always the opposite of the sign. So what that means, is if it's a minus sign in there, it's actually going to the right. And if it's a plus sign in parentheses, it's moving to the left. So So the opposite of the sign just means it goes in the opposite direction of what you would think. So a minus sign actually goes to the right, and a plus sign in there goes to the left. You'll see that in just a second. And then the last thing is a number in front. The number in front makes it narrower or wider. Now, to be fancy, there's a math word for that. So if this is a whole number, if it's not a fraction, if it's a whole number, we call this a vertical stretch. What that means is that when there's a whole number in front of your x squared, if there's a whole number right here, my graph is going to stretch vertically. It makes it more narrow. It's a vertical stretch. Now, if the number in front was a fraction, like 1/2, that's called a vertical compression. What a vertical compression does is it takes your graph and it makes it wider. It compresses, it flattens, it makes it a wider graph. So this is called a vertical compression. It's a vertical compression if the number in front is a fraction. For example, the fraction 1/2, if that was the number that was in front, it would become a vertical compression. So now if you're listening to all of this and you're like, Miss, this still does not make any sense to me, you still have a calculator. You can still plug it in and tell me which direction it went in. If you're a visual learner and you want to be able to see it, you could always still plug it in. But the purpose of today is for you to try this without plugging it in. This table makes it very easy. The number in front. Okay, the number in front, let's match my colors here. The number in the front is a 2. What did we say about the number in the front? It's called a vertical. Because that's a whole number, this is a vertical stretch. It means it's going to stretch up and become narrower. Okay, so the number in front is called a vertical stretch. The number that's inside the parentheses is right here. That number is a 4. I'm going to put a plus sign. Because that's a positive 4 and it's inside the parentheses, it means this graph is going to shift left 4. Okay, so the number in parentheses is a positive 4. If it's in parentheses, it goes left-right because the x-axis runs left-right. It's the opposite of its sign, so that's why it's left 4. The number in the back is a positive 3. Positive 3. What do we know about the number in the back? It moves it up or down. Nothing fancy. If it's up 3, it's plus 3. So to graph this from the origin, we would go to the left 4. 1, 2, 3, 4. Up 3. 1, 2, 3. Then it becomes stretched. It becomes narrower. So if you plugged this into Desmos, the graph, the graph would sit, oh my goodness, it would sit right here. Okay? It shifted left 4, up 3, and had a vertical stretch. I'm going to do one more with you, and then I want you to try a few on your own. So this next one here, the number in front, none. There is no number in front, so there's no vertical shift or vertical compression. Just put none. The number inside is the number -2. What we know about that, it's the opposite of its sign, so we're going to go to the right 2. The number in the back is a positive 1. A back number goes up 1. To graph this, I'm going to go to the right 2 and up 1. That's where my new origin is, and then it's going to open upwards, just like the parent function. So that's the change. Okay, I want you to try the next ones here. In this one here, a -3. The number in the parentheses is a positive 5. The number in the back, there's no number, so I'm going to put none. You could put 0 if you'd rather, but I'm going to put none. So this one here, be careful. We talked about negatives on that previous paper. A negative means it's going to flip. The 3 means it's a vertical stretch. You can graph this in Desmos to see it if you need to. The positive 5 that's inside the parentheses means we're going to the left 5. There's no number in the back, so we don't go up or down. So in this graph, what happens? It says going to the left 5. 1, 2, 3, 4, 5. It's flipping, so now it's opening downward. And it's a whole number, so it gets skinnier. So it's a vertical stretch. Whoops. You could also just type it into Desmos and tell me what happens. Okay, when you're ready, go ahead and try these last two. So the final question on here, this is how it would look on a STAR test. So on the STAR test, it would give you some type of a problem. I'm going to say word problem, but word problem is not necessarily the word I'm going for. But it would basically say, describe this transformation. A number in the back. Where does a number in the back go? Here it is. A number in the back. Woo. Sorry, guys. A number in the back is going to go up 3. Then we have this one. A number inside the parentheses, if it's chilling with the x-axis runs left-right. Opposite of its sign means it goes right 2. Okay, so go ahead and keep trying those. And then the last page, it just has you match from the original parent function. So from this graph here, you're going to match. So in this first one, from the parent function, where did it go? It went up 2. In this one here, here's the parent function. It's the f function, because that's what it says. Here's the parent function. So from the parent function, where did it go? It went right 2. Okay, and this one here from the parent function, here was the original one. What happened? It got wider. It ran less miles. And then letter D from the parent function, here was the parent function. What happened? It got narrower or skinnier, so it ran more miles. So now using those words, I want you to match it with its equations. Okay, so if you're confused with these, the more you practice, the easier it becomes. What you're essentially doing is just understanding a number in the back moves up or down. A number inside moves your graph left or right. A number in the front makes it narrower or wider, which we call a vertical stretch if it got skinnier, and a vertical compress if it got wider. Okay, not too bad.